Hello, Year 12. I've marked your, well, not marked, I've looked at your PAG 12s that you submitted. If you submitted it by the deadline, I've looked at it and I've sent that back to you on the original task submission. What this video is to go through some of the common mistakes that we can all learn from because they came up in almost everybody's work. But before I say that, I will say that the work is generally very, very good. You should all be very pleased with the work you've done. I'd be fairly confident of letting you loose in the lab with these instructions, as long as you make a couple of additions. But yeah, I think we'd be fairly safe to do this experiment. So the first thing that almost actually everybody didn't have was the issue in the experiment when you perform the titration, adding the potassium manganate from the burette until the first permanent pink colour appears, and then repeating the experiment until two concordant titers are obtained. Nobody mentioned anything about how you measure the amount of potassium manganate in the burette, which suggests to me that nobody actually read about it in the textbook. So in the textbook, it's chapter 23.2. It talks you through exactly how to do this titration. And you'll see in this picture here, it might not be very clear, but if you go on the website and look at it, the potassium manganate in the burette is this deep, deep purple colour. Okay, it's not like our normal acid-base titrations where you've got a clear solution in here. This is this dark purple, which means that you cannot see where the meniscus is, okay, because it's not see-through, the solution, which means that when you measure the volume in the burette, you can't use the meniscus. So unlike a normal acid-base titration, when you do this one with potassium manganate, you need to read the level of the burette from the top, okay? So it actually has this little bit here that you can read about it. So you need to, everyone be aware of that, because I can well imagine that we'd be in the lab, and then all of a sudden when it comes to reading off the burette, everyone's saying, well, hold on a second, I can't actually see the meniscus, what do I do? So you need to make sure you know about that. Okay, then moving on, we've got down here. So the one section that seemed to be a little bit lacking on most people's work was the analysis of the results. Okay, some people just hadn't got one. Some people had got one that was very brief, or some people had got one that was just a block of text. Now, you can see in this example here, what we've got is, calculate the mean titer and use this to work out the concentration of the acid mixture. All right, now imagine if you're doing this experiment 6 months from now, that's not going to be a very, very helpful direction. All right, you're going to want to see something like step number 1. Calculate the number of moles by doing this exact calculation. Step number 2. Calculate the number of moles of Fe2 plus by multiplying your answer in step 1 by 5, because that's the ratio of manganate ions to iron 2 ions in the overall equation. All right, so don't feel like it's cheating to write in exactly what to do. Okay, a lot of people have things like this where it said like, oh, now you need to use the equation to work out what the ratio is. It's like, okay, yeah, fine. That's the kind of question you'd ask someone if you wanted them to actually work that out. But I do want you to work that out. So you need to work out what the ratio is and then write that down. So that when it comes to it, you can just quickly do all the calculations. And this relates to one other thing that I think most people are lacking in their work, which I think needs to be added, and that is the chemical equations that are involved. Okay, you can see them in the textbook. There's the reduction equation, the oxidation equation, and the overall redox equation. I think everyone needs to have those equations in their work so they know exactly what's going on. Okay, all right. So moving on, we've got here. So there were lots of obviously different amounts that people used. I think it would be helpful if we had everyone using 5 tablets and 250 centimeters cubed of, or a 250 centimeter cubed volumetric flask like this person has. Okay, so some people had 1 tablet and 100 centimeter cubed. Some people had 5 tablets and 100 centimeter cubed. Okay, so all these different variations, but I think it would help if everyone was doing the same, at least the same amount. All right, so if you could change that. Also, a lot of people, so you can see this person here has got crushing the iron tablets in the pestle and mortar, which is great. I think a lot of people have had things like heating it up. I don't think we should worry too much about that. All right, I think if we use this, it should be fairly straightforward. This ratio should be fairly straightforward. Okay, next here. Okay, prepare a litre of the potassium manganate solution by accurately weighing out approximately 0.01 moles of potassium manganate. I don't know how you're going to weigh out 0.01 moles. Weighing scales don't measure moles, they measure grams. But the problem with this is anybody that's done this, it means that you didn't read the instructions that I sent out. Because it says here, chemicals, you will be provided with a maximum of 5 iron tablets and a solution of acidified potassium manganate. So that means that you do not need to make that. All right, so anybody that's included in their instructions how to make the acidified potassium manganate solution, that's not necessary because I'm giving that to you. Okay. Okay. Next we have here. So this person, they've got, they've put the iron solution, so the clear iron solution in the burette, and the purple acidified potassium manganate solution in the conical flask. Okay, so they're doing, they're sort of, they're going to be, you can imagine, titrating this clear solution into the pink solution. Okay, which is fine. You can, with titrations, you can do it either way. The maths will always work. But the because you know, you pipette this, so you know what the volume is, and you measure this, so you know what the volume is, and you know what the concentration of one of them is, so you can always work out the concentration of the other one. The problem with this titration is that the colour change, if you do it this way round, you need to see the colour change from pink to clear, okay, which might be difficult, because that bit where it just disappears is going to be hard to tell. Whereas if you do it the other way around and you titrate the pink into the clear, you'll see when we actually do this, hopefully we will be able to do this, you'll see that every drop you add in, this clear solution goes a little bit pink, and then as it reacts, it goes back to clear. Okay, but then eventually that doesn't happen. It doesn't go back to clear, it stays pink. So it's actually, it's more helpful if you do it the manganate solution into the iron solution, so that you can see that colour change. And we'll also, when we do this, we'll do it on a white tile, which makes it easier to see, like we did with the indicator with the acid base. That'll make it easier to see. Okay, and finally, just a couple of things. You need to make sure that you're using subscripts. You need to make sure that you're using superscripts. On Microsoft Word, on the Home tab, there's a little subscript and superscript button you can press that will help you do that. And the other thing is, all these things need references. Okay, it's like reading a Wikipedia article that no one's referenced. Okay, so it's wherever you've got this information from, you need to tell me in a reference. Okay, so here it says in a single tablet there's 200 milligrams of iron sulfate present. Okay, where did you get that from? Because not every iron tablet is going to have that much iron sulfate in it. You know, maybe you've gone on the Holland and Barrett website and you've chosen a particular supplement they've got there. That's fine, but you know, I need to have a reference. Okay, and down here, where did you get this chemical information from? Okay, I assume from CLIAPS, so there needs to be a reference in some footnotes for that. All right, so Otherwise, really, really good. I'd like you to make those changes and send them back to me by the end of this week, so by Friday. Well done.